Hey everyone, Matt here. Welcome back to my YouTube page. In today's video, I want to jump right into it and show you guys how to create prisms out of basic shapes. So let's start with some of those basic shapes that I've mentioned. I recommended you draw as warm-up practice. Square, triangle, circle, rectangles. Okay, we're going to turn these shapes, two-dimensional shapes, into 3D prisms. And in order to do this, I need to introduce this concept called perspective. I'm sure you've heard of it before. Perspective is essential in creating accurate prisms out of 2D shapes. And as I'll show you further into this video, you will see that everything in our reality is built out of prisms. It can be broken down into basic prisms. So I've drawn this box. This is meant to represent our field of vision, everything we see. Now, in demonstrating perspective, I want you to envision, I'm going to draw a line straight through the center. Imagine this is a beach. This is the beach, the sand, this is the sky. If you're on this beach, the furthest point you look out, you're going to see the sky meet land. This is called the horizon line. The horizon line is critical in creating an accurate shot in perspective, especially if you're drawing a comic panel, for instance. You're going to want to understand perspective innately in order to depict everything within the space of the field of vision of the panel correctly. So, horizon line. Now, let's say you're standing on the beach looking out, and you're looking at one particular point along the horizon line. Let's say right here. All right. Now, we're going to, for the sake of this example, draw a square, and we're going to turn this square into a cube. Now, this square, let's just assume it's sitting on the beach here. The square, two-dimensional, but it's sitting on the ground. Okay, let's turn this into a prism. So each of these vertices, each vertex, we're going to connect to the vanishing point. And for the sake of this exercise, this is 1 point perspective. Just so you remember, 1 point in this example. Each vertex will connect. We're going to draw right through the object. And now you've got to use something called artist discretion to determine how far back we're going to shave off these guidelines in order to create what will appear as a cube. Okay. And now, what I mean guidelines, these extra lines that we've drawn through the square using the vertices. And now we've got a very nice and accurate cube sitting on the sand of this beach. Okay, and we can even add some shadow on this side so that it adds even more dimensionality to this prism we've created. Let's assume the light source is above, and actually, since this side's completely shaded dark, it would be coming from where I'm actually looking at it, a bit more on this side here. But we're going to get into lighting and shadow in another video. For the sake of this exercise, I want to focus more on 1 point perspective, just to give you an idea of how to build these prisms accurately. So, and we see three sides of this shape because we are slightly to, three sides of this prism. Remember, it's a prism now because we are slightly to the left of the location of the vanishing point. If we draw a vanishing point here, and let's say I draw a rectangle that is right below, we're not going to see three sides because, again, drawing from each vertex, drawing through it again, connecting to the vanishing point 1, vanishing point 2. Let's say we make quite a long rectangular prism, Another thing I want to point out too on the cube here, these lines are parallel to these ones that we've, actually this one could have drawn through it here so you can see. There's your cube. Looking through it, as if it was transparent. Same with the rectangular prism we've now created. These are all guidelines, because if this was a block, we wouldn't see through it. So we can erase these guidelines, and now we've got a rectangular prism. And again, you can situate it, adding a little bit of textural detail to this ground, have it sitting in the sand. Okay. Maybe the light source is up here for this prism, and this is shadow here. This side is completely shadowed. We're going to save the lighting. I keep getting into it. It's very tempting. But focusing on 1-point perspective. And again, like I was saying, you'll see two sides because it's placed directly below the vanishing point. If it's to the left, you're going to see an extra side, 3 sides. And again, if I drew this cube, if I built a cube on this side, using even the same vanishing point, again, drawing through, just for practice, to learn these rules, you're going to see, and because it's further away, you're going to see more of the, so we're going to have to make a judgment call here to make it still look like a cube. And parallel, and this line, parallel, and we've created now a new set of vertices. And if you wanted to just see the cube in 3D, drawing through it, and there you go. This side, you're going to see more of this side because it's that much further away to the right of the vanishing point. So these prisms have been built on the ground. Now you can do the same in the air, especially if you're trying to draw, let's say, a plane. In this case, let's draw a triangle, just to keep it simple. We'll draw a triangular prism, and we'll do it using maybe a vanishing point over here, vanishing point 3. So again, we're going to, and I recommend a ruler with this, doing this with a ruler until you get stronger or more confident drawing straight lines. It's still good practice to draw these straight lines, but to get it completely accurate so you can see that you've built a perfect prism, I do recommend a ruler. So, and I've kept this triangle simple because this bottom lines up parallel with the horizon line, and then parallel, we can cut it off here, and then at the base where this new vertex this point has been created, we're going to line it up down here. Now we can erase our guidelines, and we've created a triangular prism in the air, and I've put shadow underneath specifically to show that the light is completely hidden underneath because it's in the air and it's above ground, and it's above the horizon line. If you want to see underneath an object, a prism, you're going to draw it above the horizon line. And if you want to see the top surface of a prism, you're going to draw it below the horizon line. Very simple, 1-point perspective, keeping it simple. If you were to draw this triangle as a pyramid, actually, let's tilt it a little bit, make it a little more challenging here. So we've got a triangle looking like this, and it's going to be a triangular based pyramid. Put a horizon or a vanishing point right here. That's VP4. Vertex to vanishing points. And now you're going to choose a point along okay. So now you can see it looks a little bit strange, but it's because this prism is on a tilt. So let's, when I color this in, when I shade this in with shadow, now you can see your triangular based pyramid is on a tilt pointing downwards towards the horizon line. So this point right here is the closest to land. All right, so that, and I just made this decision to where to put this point. I made the decision considering that we want it to still look like an equilateral, because this is an equilateral triangle. So we want to make each side look even, just like I did with the cube. I made a judgment call on how far back I was going to pull it to keep it looking like a cube. If I pulled it back here, it would be a rectangular prism and not a cube. All right, so now that we know basic perspective, I also want to point out that you can have a shape of as many sides as you like. It can be something completely wild. And you can apply perspective to this. All you do is line up each vertex to the vanishing point so they'd all converge. And then you just decide how thick you'd want this object to be. And then you just parallel. And now you've got a very strange looking prism with many sides to many edges to its face. Okay. Now that we know how to build accurate prisms in 3D space on a 2D surface, everything that you see in reality is built out of structural shapes. It can be broken down into basic structural shapes. In later videos, when I get into anatomy, breaking down anatomy, I'm going to use those shapes to depict different parts of the body. For now, let's keep it really simple with some examples. Think of an ice cream cone. The ice cream is a sphere. And for the sake of showing you what a sphere looks like without getting into light, you can imagine the surface, the way that light would curve around these ellipses that I've drawn here. Kind of looks like it's made of wire, just to show you what a sphere looks like in 3D without shadows and light, but on a 2D surface. And then, of course, the cone. The cone is a cone. You've got your ellipse, draw a center line for accuracy. And because there are no vertices on a circle, you take the edges and you line them up to that point you've determined for the length of the cone. And you can see if we were to, that's a shadow, maybe it's hollow, maybe it's a flat surface. For a cone, obviously it's hollow. And the ice cream will fit inside the cone. In later videos, I'll get into depicting detail, surface detail. Obviously, that is not something to worry about yet if you're just learning. You want to get things down structurally correct. You want to break everything down using perspective. And this takes a lot of practice. It will take a long time for you to really wrap your mind around seeing things structurally and drawing through objects. When you do a study, it's always best, I still practice this, drawing through the objects, getting their structure down before I apply any surface detail. Think of surface detail as the icing on a cake. I mean, let's draw a cake. What is a cake? It's just a cylinder. And you can, of course, add layers to this cake, like a wedding cake. Just keep stacking the shapes up. If I want, now I'm looking very, I'm seeing the top. I'm seeing the top of this cake. If I looked at it directly, it would just look like rectangles stacked on top of each other. Because the horizon line is, well, if I was looking directly at it, I'd still see a little bit of the top perhaps, or a little bit of the bottom. Maybe the horizon line's like right here, like right down the middle of this, like this height, this total height. Somewhere around the center of that height would have me looking at these stacks of cake, and they'd be looking like rectangles, but they're actually cylinders. See, now I'm looking at more of a little bit of the top surface, more of the top surface, because the horizon line is now above, it's above the cake. I'm looking down at the cake. And if I look up, I see the horizon line. let's see, if we were to build, let's build a phone. Breaking your smartphone down into its structural shape, it is a rectangular prism. Very simple. And again, I'm drawing this without using what I just explained, using this diagram of perspective and how to apply the rules. I just want to point out also that perspective, everything that we see in reality adheres to the rules of perspective. Doesn't matter if you're on a cliff, if you're on the ground at sea level, if you're sitting in a chair, when you look forwards, there will be a horizon line where the sky meets land. Even if you're 100 floors up in a building, you're still going to see that horizon line, and it never curves. It's always straight, and these rules don't change wherever you are on Earth. Okay, on land, of course. So getting back here with the phone example, this will be the last thing I demonstrate in this clip. I think it's worth noting here. We're going to take this further in the next video. So and you're going to find also that these lines, see, I've drawn this without using any guidance because I'm visualizing, and a lot of these vertexes meet up quite accurately because I'm very carefully watching and laying down these construction lines here, and I've drawn through it to build this properly. Now at these points, it's great practice to, I'm going to lightly erase these inner lines I've drawn to show you what I'm going to do next. This will be the last thing I point out here. You always want to mark off the center points of surfaces so that you can add detail accurately within or on top of the face. So mark off the center here. On this side, mark off the center. Now you have a good idea of where the, and parallel, this is the exact center of this prism right here on this face. And even within here, you can find the center of this space. The center, and again here, we have the center here, parallel. Center's right here. Now you can draw right through. Now we've got a perfect center line through this prism. And it's very useful and helpful if you're trying to depict something accurately, even if you're doing a study. Finding these center lines so you can build off the detail from them is going to really help in depicting a very true to life representation of what you're trying to draw. So I want to thank everyone for tuning in, and if you stayed this long, I am absolutely grateful and thankful. And if you found anything useful, and if you enjoyed this video, please consider subscribing, liking, and absolutely leave your comments, because I love responding to questions and hearing your feedback. All right, friends, I, again, hope you enjoyed this, and I will be back with more videos real soon. Have a great one. Take care.